We're here at the Holiferm R&D lab to talk about the challenge of mixing stable emulsions.
Yes, that's right. So this is a formulation that I've come up with. It's a cleansing lotion, and you apply to your face. It goes milky on contact with water, and then it washes away and it leaves your skin lovely and silky smooth afterwards. We're using the Holiferm sopholipids to help with the emulsification and also, of course, for the cleansing, microbiome and barrier support. I'm using the LF, it has the HLB of 11, and the HF has the HLB of 17, so that makes the required HLB of our oil phase here. And then what we're going to look at today is the difference between high shearing on a Silverson versus a standard overhead stirrer. I'm just going to add some hot water to our water phase so that it's the same temperature as the heated oil phase here.
Okay.
And then we can pop it under.
Great.
So I'm going to add the water phase straight in.
And of course, it has formed an emulsion, but the key thing is it's not a stable emulsion. And the stability is everything on formulations like this, isn't it? Because of course, these products need to be sat on the shelf, sometimes for a prolonged period of time. But not only that, once they're purchased, it's going to have it on their shelf for some time, and they want to use that product over and over again, and they don't want it splitting or not performing the same way as it did on day one. And when we're looking at how the Silverson impacts this, the high shear action of the Silverson has the effect of creating these really small droplets in the emulsion, and that's what we tend to find really impacts the long-term stability and prevents those droplets coalescing together.
Yeah.
So although it looks that way now, I'm sure if we stop stirring it, it'll probably start separating soon.
Yeah, it would start to separate immediately. And you can tell by the colour as well. The moment we put this on the Silverson, you'll see it will go much more white, which shows that that particle size has really
Absolutely,
decreased. Yeah. I'm going to split this into two for the purpose of this demonstration. This one can go on the overhead. That's great. Perfect.
Yeah.
So that's going there at a reasonably decent speed. And then we'll move over, so you can see this is what happens between the water and the oil phase. So immediately we're going to see this whiteness appear.
Wow, straight away. It's immediate colour change, isn't it?
Okay, so at this point, I'm going to take samples of both formulations, and then we'll head over to the microscope and see what they look like. So this is a lovely emulsion now. Really tightly compact, homogeneous mix of oil and water. These little bits are just air in there, which we would expect.
And not only are they really small, but they're also really uniform, aren't they? I mean, these little droplets look identical, really.
Yeah, they're lovely. And then over to the overhead stirrer one, which are visibly larger.
Yes, and you've got some small ones in there, some big ones.
We haven't got that same uniformity.
When we talk about droplet size distribution, this is a very wide distribution.
Yeah.
Whereas as a result of mixing on the Silverson, we've got a very narrow distribution, and they're all very small, which is what we tend to see leads to very high stability.
Yeah.
Clarissa, thank you so much for inviting me over here to the R&D lab and showing me how you use your Silverson machine.
Yeah, thank you. Thanks for coming along and seeing what we do here at Holiferm. And I've learned so much more about my machine as well, so thank you for that.